Okay, momentum quiz number 8. A 3 kilogram ball moving at 5 meters per second bounces off a wall and moves 4 meters per second in the opposite direction. Fred says the impulse is 3 Newton seconds and Barney says the impulse is 27 Newton seconds. Who is correct? So impulse, you have to keep in mind, impulse is simply delta P, change in momentum. Okay, so I don't want to look at this as much using equations, only momentum. Let's just think about this momentum. If I have a ball and has a certain velocity going this way, it's going 5 meters per second, and it hits a wall, and now is going the other way at 4 meters per second. What just happened here? Okay, so let's talk about the momentum going to the right and the momentum going to the left. One thing you need to keep in mind is that the velocities are going in opposite directions. So let's look at the momentum before. The momentum here was 3 times 5 going into the wall, which is 15. And then leaving, the momentum was 3 times 4, which is 12. Okay, so 15 and 12, you have momentum 15 and 12. There's a couple of things that could yield. You could either think of them as adding and getting 27, or you could think of it as the other way, minus 12. And where you'd have 3. So that's where the 3 and the 27 come in. Because you could add or you could subtract the momentums. And on the quiz, most people did this, which is actually wrong. The way you need to think of this, the change in momentum. So how is the momentum changing? How is this changing? You have momentum going to the right. And afterwards, after the ball bounces, the ball is going to go to the left. So you have changed the momentum of the ball. Now, if I look at just the first part up here, to change the momentum is going to go from 15 to 0. So I was going 15, then I was going to 0. That is a change in momentum itself. So from 15 to 0, and then from 0 to 4, or 0 to 12. So we've changed the momentum in two ways. One, you have to stop the ball, and then you have to move it again, but in the opposite direction. So basically what you're doing is you need an amount of momentum, change in momentum, that's 15, and then another amount that's 12, add them together to get 27, accelerating to the left. Okay, so Barney is going to be right, it is 27. The other way you could look at this is if you wanted to look at change in momentum, you could do P final minus P initial. Look at this more mathematically. So final momentum -4. See how it's -4? Because it's going to the left, minus the initial, which is 3 times +5. So what I end up getting is -12 minus 15, so -27. That's what Barney says. In the problem he says 27. It didn't say negative, but the idea here is the impulse has to be a magnitude 27. Now, technically, Barney should have said that the impulse is 27 to the left. And that would be more accurate. But even if you didn't say that, an impulse of 3 Newton seconds would not be enough to affect the ball that was going to the right, since that one had 15. An impulse of 3 Newton seconds would only change that to either 18 if you sped it up, or it could be 12 if you slowed it down. But in either case, the momentum is still going to the right. You definitely need a momentum of 27, or an impulse of 27, in order to move it back to the left. You have to overcome the 15 and move it to the left.